Peace be upon you, dear viewers and students. In our lesson for today, we will continue the previous lesson, the basic rules for the derivative. Chapter 3, Lesson 2, Part B. Please do not forget to subscribe the page and write your comment if you have any question, and press the button like to encourage us. And now let us start our lesson. Thank you for watching. Theorem 3.5 Product Rule. The product of two differentiable functions is the differentiable function. If we have f of x multiplied it by gx, the derivative of them is equal fx multiplied by derivative of gx plus gx multiplied it by derivative of fx. That means the derivative of two product function first time derivative of second plus second time derivative of the first. You can change or say in another way, say the second derivative, then time first plus the first derivative time second. Example, find the derivative of f where fx is equal 3x squared sine x. The first one is 3x squared and the second one is sine x. There is a product between them. And now the first one is 3x squared and the second one is sine x. Take the derivative of 3x squared, which is 2 times 3 is 6, 2 minus 1 is 1, then it is 6x. And the derivative of sine x is cosine x. Not to do this thing, work directly to find the derivative. And now the rule says f prime of x is hx times g prime x plus gx times h prime x. And now f prime of x is equal, where hx is the first one, then we get 3x squared right here. Then g prime of x, which is the derivative of the second one. For the sine, the derivative of the sine is cosine, then write cosine here, then plus, then gx, which is the second one, it is sine x, then multiplied it by the derivative of the first one, which is 6x. Simplify them, then f prime of x is equal 3x squared cosine x plus 6x sine x. Find the derivative of f where fx is equal minus 2x cubed cosine x. The first one is minus 2x cubed and the second one is cosine x. And now find the derivative of them. The derivative of the first one is minus 6x squared and the derivative of cosine is minus sine. And now f prime of x is equal gx times k prime x plus kx times g prime x. And now gx is the first one and kx is the second one. Gx is minus 2x cubed, right? Minus 2x cubed. Then the derivative of the second one, which is minus sine x plus, and the second one, which is cosine x, time the derivative of the first one, which is minus 6x squared. Simplify them, then f prime of x is equal to x cubed sine x minus 6x squared cosine x. Theorem 3.5. Division rules. If f and g are two differentiable functions, then the function f over g is differentiable function. If we have f of x at a numerator and g of x at the denominator, then the derivative of them is equal. Gx, which means the denominator, time f prime of x, which means the derivative of numerator, minus fx, that means the numerator, time g prime of x, which is denominator, derivative of the denominator, over the denominator square. It have one condition, that gx not be equal to 0. That means the derivative of division for two function is denominator time numerator derivative, numerator time denominator derivative, then denominator square. Example, find the derivative of the function f of x is equal 5x minus 2 over x squared plus 1. As we done before for the product, here you can do the same thing. Write the numerator, which is 5x minus 2, and the denominator, which is x squared plus 1, and find the derivative of each of them. The derivative of 5x is 5 minus the derivative of 2 is 0. Then the derivative of 5x minus 2 is 5. The derivative of x squared is 2x plus the derivative of 1 is 0. Then it becomes the derivative of denominator is 2x. F prime of x is equal. The first one, we must write the denominator, which x squared plus 1, x squared plus 1. Then multiply it by the derivative of the numerator, which is 5. Then minus. Then write the numerator, which is 5x minus 2, time the derivative of denominator, which is 2x. And now write the denominator at the denominator, then it becomes denominator x squared plus 1 squared. And now simplify the derivative. 5 times x squared, 5x squared. 5 times 1 is 5. Minus time plus is minus. Then 5x times 2x is 10x squared. Then minus time minus is positive. Then 2 times 2x is 4x. 5x squared minus 10x squared is minus 5x squared. Write 4x plus 5 over x squared plus 1 squared. Another example, find the derivative of f x equal 3x minus 7 over x squared minus 1. Numerator is 3x minus 7 and denominator is x squared minus 1. The derivative of the numerator is 3 and the derivative of denominator is 2x. Then f of prime x is equal the denominator, which is x squared minus 1, time the derivative of numerator, which is 3, then minus the numerator, which is 3x minus 7, time the derivative of the denominator, which is 2x, and write the denominator square at the denominator. Then simplify the example. 3 times x squared is 3x squared. 3 times minus 1 is minus 3. Minus 3x times 2x is minus 6x squared. Minus times minus 7 is plus 7 times 2x, 14x over x squared minus 1 all square. Then simplify. Minus 3 plus 40x. 3x squared minus 6x squared is minus 3x squared. Prove the differentiation rule for the function f of x is equal tangent x. We have f of x is equal tangent x. First of all, write tangent x as a sine x over cosine x. And now you have a numerator is sine x and denominator is cosine x. The derivative of sine is cosine and the derivative of cosine is minus sine x. Then f prime of x is equal, first of all, write the denominator, which is cosine x, times the derivative of the numerator, which is cosine x, minus then the numerator, which is sine x, times the derivative of the denominator, which is minus sine x, all over denominator, which is cosine x squared. Simplify. Cosine times cosine is cosine squared x, minus times minus is plus, sine times sine is sine squared x. As we know that cosine squared x plus sine squared is equal 1, then 1 over cosine squared x, which is the rule of the derivative for the tangent x. We have another rule for the tangent x. To find that, supply this equation to the particle fraction, which is f of prime x is equal cosine square x over cosine square x plus sine square x over cosine square x. As you know that cosine square over cosine square is 1 plus sine over cosine is tangent, because both of them are square, then it is tangent square x. This is the second rule for the derivative of tangent x. Example, find the derivative of fx equal 1 over tangent x. Fx is equal 1 over tangent x. Change the tangent x to the sine x over cosine x, then take the inverse of it. It becomes cosine x over sine x. And now your numerator is cosine and denominator is sine. The derivative of numerator, that means the derivative of cosine is minus sine, and the derivative of sine is cosine. And now f prime of x is equal, first of all, write the denominator, which is sine x, times the derivative of the numerator, which is minus sine x, the numerator, which is cosine x, times the derivative of the denominator, which is cosine x, over denominator square. Simplify. F prime x is equal minus sine square x minus cosine square x over sine square x. And now take a minus 1 as a common factor for the numerator. It becomes minus sine square x plus cosine square x over sine square x. As you know that the sine square x plus cosine square x is 1, therefore it becomes minus 1 over sine square x. Example, which one is the derivative of fx equal 2 over 1 plus sine x? As you know that here numerator is 2 and the denominator is 1 plus sine x. And now the derivative of the numerator, which is 2, is 0, and the derivative of denominator is the derivative of 1 is 0 plus the derivative of sine x is cosine x. Then the derivative of denominator is cosine x. And now f prime of x is equal, first of all, write the denominator, which is 1 plus sine x, times the derivative of numerator, which is 0, minus the numerator, which is 2, times the derivative of the denominator, which is cosine x. And now write the denominator square. Simplify. 0 times 1 plus sine x is 0. It remains minus 2 cosine x over 1 plus sine x square. As you can see that the B is a correct answer. Theorem 3.3. Sum and the difference rules. The sum and the difference of two differentiable functions is a differentiable function. fx plus gx derivative is equal fx derivative plus gx derivative over fx minus gx derivative is equal fx derivative and gx derivative minus. Example, find the derivative of each function. F of x is equal x cubed minus 4x plus 5. As you know that the function f of x is sum and subtract of three functions. To find the derivative of it, take the derivative of each function along. That means the derivative of 3x cubed is 3, right? 3x. 3 minus 1 is 2. That means 3x squared. Then write minus. And the derivative for 4x is 4 plus the derivative of 5 is 0. Then the answer B, f prime of x is equal 3x squared minus 4. Find the derivative of each function. A, fx is equal minus x to the power 4 over 2 minus 3x cubed minus 2x. To find the derivative of this function, take the derivative of each function along. The first one, minus x to the power 5 over 2, the derivative of it, because you have a constant at the denominator, then the write a constant as is it. Then you have minus and write minus 2 minus. Then take the derivative of 4x to the power 4, then it is become 4, then x. 4 minus 1 is 3. Then it become minus 4x cubed over 2. Then write minus. Then the derivative of 3x cubed. 3 times 3, 3 times 3 is 9. Then x. 3 minus 1 is 2. Then minus. The derivative of 2x is 2. Cancelling 2 with 4, it becomes 2. That means minus 2x cubed minus 9x squared minus 2. B. F of x is equal x plus cosine x. F prime of x is equal, the derivative of x is 1. The derivative of cosine x is minus sine x. C. F of x is equal square root of 2x plus 2 ln x to the power 3. This one, first of all, write 2 square root of the function 2x. Then take the derivative of 2x and write it at the numerator. Then write these two times the derivative of ln x cubed is 3 over x. You have another way to find the derivative. You can, first of all, supply this function, the square root, it becomes square root of 2 square root of x. And now here, 3 times 2 is 6 ln x. After that, take the derivative, which is equal 2 square root of 2 times 1 over square root of 2 times square root of x. And now plus 6. The square root of ln x is 1 over x. To simplify them, and you can see is the same answer. D. F of x is equal e to the power 1 plus cosine 2x plus ln of 2x plus 1. F prime of x is equal. First of all, take the derivative of the power, which is 1 plus cosine 2x. The derivative of 1 is 0. Then the derivative of 2x is 2. And the derivative of cosine is minus sine 2x. Write this function e to the power 1 plus cosine 2x as it. Then plus. Then take the derivative of the 2x plus 1, which is 2, over 2x plus 1. Another example, find the derivative of each function. Fx is equal tangent x over 2 minus 1 over 2 sine x. First of all, take the derivative of tangent x, which is 1 plus tangent square x. Then minus, write 1 over 2 because it is constant. Then the derivative of sine is cosine. You have another way to find the derivative, which is f prime of x is equal. The derivative of tangent x is 1 over cosine square x, and write 2 as it. And this part is not changed. Fx is equal 1 over 2x minus cosine x. F prime of x is equal, write 1 over 2. Then the derivative of x is 1 plus the derivative of cosine x is minus sine times minus is plus sine. Here we came of the end of the lesson. Please subscribe the page and share it with your friends so that everyone benefit and get each new videos. Write your comment and press like button. Thank you for watching and goodbye.